Should I start from the very beginning? This talk very much is based on my book, High Performance Java Persistence. For a living, I work for Hibernate, for the Hibernate project. I'm a Java champion, and that's my blog where I keep on posting articles on a regular basis. Okay, now, the reason why I wanted to give this talk is because when it comes to database, to data access layers, it's quite, it happens to, for many applications to encounter performance issues. And this code was taken from application dynamics, and they are building an application performance monitoring tool. They are monitoring lots of applications, and they realized that more than half of application performance bottlenecks, they said that they originate in the database. Actually, it's not true because it originates in the data access layer. It's not just the database itself. So, apart from what is typical, you know, we care about performance because performance means that from the user perspective, the application is more responsive and it's going to be easier to use. But however, there are also things which are not always obvious. Like for instance, the site speed is taken into consideration by Google when they build a page rank. So if you're having competition, you want your site to be served faster than your competition, because that will probably get your site to be in the first results when you do a Google search. And for instance, that one, you know, if you take a look, this one, it was taken from a conference, from a Velocity conference in 2008. And back then, 10 years ago, if you think about, Amazon said that for every 100 milliseconds of extra latency, they would lose 1% of profit. So you can imagine what's 1% of profit when it comes to Amazon. And that's related to performance. So that's the main reason why we want to talk about performance in the context of databases and Hibernate. So basically, the agenda is going to be this. First, we're going to talk about performance and response time. And in order to envision what's response time all about, we have to think about, in a typical application, we can monitor performance and response time at any boundary, at any layer. Here, we are going to monitor it at the transaction layer. And if we inspect it, we can see that in order to execute statements and when we interact with the data access layer, there are several things that we need to do, and all those can be optimized. For instance, we need to get a database connection. Afterwards, we need to execute the statements, but we can prepare them. We can optimize that. We can optimize the queries, the traversing of the results set, and then what people don't always realize, there's some extra application performance, that might be incurred there if we are holding onto the connection and we're doing application level processing, but we don't give the connection back to the database. So all those steps, if we can improve them, we can improve the overall application performance. So basically, response time. You might hear it. Some people call it latency, which is not true, because latency is it's a different term in physics. Latency means, for instance, what's the latency of air when I transmit a signal, or on a fiber optics, or for instance on a Wi-Fi. That's latency. Well, much better term is response time. Response time because it's the time it takes from when you initiate the request until you get back the response. Okay, now related to database connections, you know, the reason why we're using a connection pool, you know, it's pretty much well known that it gets you extra performance. But what's the, if you are to compare it against, if you're not using a connection pool solution, you will get something like that. The database names are obfuscated for very good reasons. Yeah. Now, on this graph, what I want you to take a look at, we don't have just the average, because the average is misleading if you're taking the average on very long intervals. Usually, you need both the average and the percentiles, because the percentiles give you a much better perspective, and percentiles can also capture the traffic spikes. So here, if you compare, it takes 20, 10, or even 50 milliseconds to get the database connections. So if you have a database which takes 50 milliseconds to get a database connection, you can get a throughput of maximum 20 transactions per second per connection, which is actually very, very low. But on the other hand, if you're using the Hickory connection pool, which is probably the fastest one you have in Java, you get your database connection in 10 microseconds. So it's so fast that's not going to be your bottleneck anymore. However, in Hibernate, when you're using it, you have multiple options. Hibernate has an abstraction over the connection, the way you are getting your connection from the database. So you have the connection provider interface, which has multiple implementations, like C3PO, Hickory, data source, or driver manager connection provider. So which one of those is the best to use? Which one? How many of you think that is 3CPO? Raise your hand if you think that's a good idea. Nobody wants to. Hickory? Hickory is good, yeah. The driver manager connection provider? No. Or the data source. Does anyone think that the data source is good? Let's see who won. It's the data source. So why is the data source? Is because it gives you an abstraction from the application perspective. You're just using an interface, so you don't have to, the application does not have to know what's behind that interface. So then you can configure whatever data source. You can have multiple proxies there for multiple responsibilities. Like you can have Hickory, but you can also log your statements along with their parameters and extra information using data source proxy, and you can even monitor connections with FlexiPool. With another tool. So from this one gives you much better flexibility if you're using, not just if you're using Hibernate, if you're using actually any application that needs to connect to the database via Java. Okay, now the next thing that you need to think about is in a typical application, you have something like that. You have one master or primary node, and then you have multiple followers. But then you have the front-end nodes, you have batch processors that import data, do full text search, send emails, and all of those needs connection to the database. So how do you set up the connection pools? Because those can be auto-scaled. So in a way, you have to make sure that you provide the right connection numbers, because otherwise you will deplete all the connections. And you cannot just set one server to have 1,000 connections, because it will not work. It's the same like with the JVM. You cannot just start 20,000 threads in a JVM and expect to work faster. In order to end, we had this problem. Before working for Hibernate, I used to work as an architect. So we had a system like that. We had to push it into production. So we asked ourselves what we can do about it. And because we didn't find a good answer to this, I had to build this tool, which is called FlexiPool. It's an open source framework that you can get it via Maven Central. So practically it's just a proxy over data source, and it allows you to monitor the connection pools. It supports all the major connection pools you have in Java, and it provides you a lot of metrics, and we will see what metrics you can get from that. So for instance, you get how many concurrent connection requests were being sent to our application. Here you can also see why the mean, which is the orange one, located at 0.5, doesn't give you very much information. So if you're taking just the average, 0.5 connections would be sufficient. But then if you take the 99 percentile, you see that it fluctuates between 2 and it goes even to 6 or even 8 connections. Or you can see how the pool size is growing over time, or you can get how much time you had to wait to get a connection, or how much time you had to hold on to a connection. So here, if you don't see something like that, you don't know how much a transaction might take. But here, when you have a graphic like that, you can see that there's something fishy going on towards the end, because one transaction took and hold a connection for 35 seconds, which is a long-running transaction, which is really bad. Probably it must be broken into multiple steps using a batch processor, multiple jobs or something like that. Okay, now the next thing in Hibernate, which related to connection, which you have to take into consideration, is the way connections are acquired. If you're using JTA, which is typical for Java EE, connection is going to be acquired as needed when you actually want to execute a query or a statement if you flush the persistence context. But if you're using resource local, which is typical Spring Boot, that's you're being on the resource local side, so the connections are going to be fetched immediately. Why? Because Hibernate does not know if the underlying connection was set to auto-commit false. Otherwise, you know, when you get from JDBC, you get a connection. If you get it from the driver, by default, the auto-commit is set to true. So you want to set it to false, because otherwise every statement is going to be executed in its own transaction. And Hibernate does not know that, so it has to set, to get the auto-commit flag, and if that's set to true, it has to set it to false. But because it needs a connection, it has to acquire it right away, right where you have the transactional annotation. So where things can go wrong if you have something like that. So you have a transactional annotation, but then inside you are reading an XML document, you are parsing it, and then you are persisting the entities. But the problem is that you started your transaction here, and that might take 100 milliseconds, and that might take 50 milliseconds. So you're holding to a connection which does not do any work. It's just in idle, and that might take time. And in Hibernate 5.2.10, we introduced this property, provider disables auto-commit. So if you set to the data, if you're using a connection pool and you set the connection pool level to always set the auto-commit flag to false, you can tell Hibernate that Hibernate should not think about this, so it should not inspect the auto-commit flag, so it can acquire the connection lazily. And if you run that test, you will see that the gap between the blue and red is how much processing time it took. So here is actually how much you really needed the connection. You only need it for 40 milliseconds, and otherwise it takes 120 milliseconds. So the gap between here it was the processing time which you did. And if all requests hold on to the connections and they're not doing their idle and they're not doing processing, other requests might not use the database and they might need them. Okay, so the next thing to discuss is about identifier generators. Usually people think that there's not much to discuss about. You just put the ID generated value, set it to auto, and you can call it a day. However, there are things to consider. For instance, if you're using the identity, in Hibernate, if you're using identity, you cannot use JDBC batch inserts, because by the time flush comes, Hibernate already executed all the statements one after the other, because it needs the ID to put the ID as a key in the persistence context. If you're using MySQL 8.0, which is the latest one, it still doesn't support sequences. Fortunately, if you're using MariaDB, you can upgrade to 10.3, which supports sequences, so you can benefit from batch inserts as well. The sequence plays very well if you're using JPA in Hibernate. Nowadays, it's very much supported by all major databases, like, for instance, you have it on Oracle, Postgres, even in SQL Server. And if you're using sequences, Hibernate offers some optimizers, like pooled and pooled low. If you're using Hibernate 4, you have to activate it using this property. If you're using my Hibernate 5 or later, it's enabled by default, so you don't have to do anything. So what's the deal with these optimizers? For instance, if we are having this one entity which has an identifier and it has a sequence generator, we can set the allocation size to a value which is greater than 1. And what will happen is will happen something like that. So at first, the pool optimizer takes the maximum value, which can be maximum value, which will give the what identifiers you can generate. So here, at first it's 1, so it's it has to get another call, so it gets to 4. Once you have 4, you can generate 1, 2, 3, and 4. Afterward, when you one second. Do we need to do anything here, or? Okay. So once you got to and you generated 4, then you need another sequence. You will get, the sequence is incremented 3 by 3, so you'll get the next value, which is 7. So you can generate 5, 6, and 7. And if you have someone in between, which doesn't know that you are using this optimizer, they can still use. Like, for instance, you might have DBA, or you have a different application using your database. They can still use and generate the sequence and use it as an identifier, because after they use it, they generated 10. When you need another one, you will get 13. So you can generate 11, 12, and 13. So you'll never get a conflict between, even if you're using multiple applications. And that you have it in Hibernate 5 for pooled and pooled low, and even you got it before, even in 4 and 3. The problem is that previously The high-low generator used to do something like that, but that's not very useful because you might get conflicts. So if you want to use an optimizer for the sequence, use pooled or pool-low, which work pretty well. So for instance, what you can gain, for instance, calling a sequence is actually pretty fast. If you see, it takes 0.35 milliseconds to call it. However, if you execute 50 of them, you will see that calling all of them one by one will take more than calling, if you call 50 in a row, one by one, instead of calling only one time, you will save some time. So that's how the optimizers work. The next one, the last one is the table generator, which you shouldn't really use it because it uses row level locks. It needs a separate connection, a separate transaction in order to generate the sequence. Because the sequence is emulated, it has to be non-transactional from the root transaction point of view. It can also use the optimizers because it emulates sequences, and the same property is used to activate the new optimizers. However, if you take a look, it takes, even if you call it one time, it takes 0.5 milliseconds up to 2.5 milliseconds. So it takes much more time than when you call a database sequence or, for instance, identity. Now, if you have to compare how identity or table perform one to another, you might have this if you're using MySQL. You get something like that. So the more threads you are using, the more connections you are using, you will see that table doesn't really scale because everything will come down to the way the sequences are allocated because you have to take locks. So everyone will go back to a single lock, which is bad. So it doesn't scale very well compared to identity, which is non-transactional. Now, the problem here, what might be that, for instance, if you're using before Hibernate 5, when you use auto in MySQL, it will use identity because it was the native generator. Nowadays in Hibernate 5, if you're using auto with MySQL or MariaDB prior to 10.3, it will go back to table, which doesn't scale very well. So you have to pay attention to when you use auto. Now, of course, if you want to compare sequence to table, you might, it's quite obvious the sequence will perform better because every time you have something for real comparing with something which is emulated, the one which is real works better. So it looks something like that. So yeah, the table generator is not very useful. If you can use sequence, use the sequence. Otherwise, for MySQL, it's better to just use identity because the table doesn't really scale very nicely. Okay, now the next thing is about database and the relationship, the association you can have among entities. Everything can be boiled down to a single picture here. So there are many ways to write to expose the relationships in the database. On the database side, things are pretty much simple. Everything is based on the foreign key. So you can have many-to-one. If you're sharing the primary key, you can have on one-to-one. Or if you're using an intermediary table, you just get the many-to-many. So that's it. It's pretty simple. But then in JPA, you have an explosion of combinations. You can have many-to-one, one-to-many, unidirectional, bidirectional. It depends on the collection size. You can use bytecode enhancement. So basically, which one are good? Everything that's based on many-to-one is perfect. If you want to use one-to-many, the bidirectional one performs very well. If you're using sets with one-to-many, it might perform a little bit worse. And the worst of all is the one-to-many unidirectional with list. For one-to-one, the best one is when you're using one-to-one with maps ID because you're practically sharing the primary key, or if you're using bytecode enhancement on the map by side. Otherwise, it can lead to n+1 query issues if you're not using that. For many-to-many, if you're using the annotation, with set is okay, with list is not. And it's also okay if you're just mapping the intermediary table and then you're using many-to-many there and one-to-many on the other sides. So basically, it looks something like that. So not every annotation is okay to use. From a performance perspective, you want to be on this side. Okay, now related to batching. Batching helps us to reduce the number of round trips when you are writing to the database. In Hibernate, you have two settings. One is for the session factory, is a global one, applies to every session, and you can also override that since Hibernate 5.2 on a per session level basis. What's nice about Hibernate, and you don't get it in JDBC or other frameworks where you issue all the statements manually, is that Usually, it's quite rarely that people will use it from the very beginning. People will start only when they would get some problems in production. They will analyze, realize that batching makes sense, come back to the application, rewrite the data access layer, because the code is different. In JDBC, you have execute update if you don't using batching, or you have add to batch, execute batch. So you have a completely different API. So you have to make a choice. So you have to change the data access code if you want to enable batching. In Hibernate, you don't have to do that. With just one single property like that, you can switch from non-batching to batching, so you don't have to rewrite your code in your data access layer. And you can even override it on a per session level basis. Here, it's just the API. You can just set it. You unwrap the entity manager, and then you call set JDBC batch size. And you don't have to do it manually. You can even create one annotation in Spring and use an aspect and do that automatically. So you don't really have to do it manually if you want. On at some point, probably Spring will offer something like that. So once you apply batching, what will happen? If you're logging your statements, and why it was nice to use the data source provider, because we can chain, you know. Have you ever heard of data source proxy? This framework is open source, Maven Central. Have you ever heard of it? Yeah, only one? It's still better than none. So yeah, this is a very small framework. It allows you to log. Actually, this is exactly the log you get in your application. So you get the exact statement which was executed. Every statement in Hibernate is a prepared statement, so you get bind parameter values there, so you don't know what actually you sent to the database. But if you're using data source proxy, it will log the parameters. So here, because we are using batching, here you see batch is true, we can see the exact set of parameters that was sent to the database. You can see that the query size was 1 instead of 10, because only the batch size was 10. We only went once to the database. And yeah, that's one advantage of using, and you can also even get the time it took to execute this statement. So it works if you compare. By default, you are here at 1. So if you're inserting 5,000 records and even just set the batch size to 10, you'll see that the performance improves quite significantly, because instead of executing 5,000, actually, instead of going 5,000 times to the database, if you're using 10, you're only going for 500 times. So you saved 90% of execution. So it's exactly like, you have to think about it, it's like when you're doing shopping, so you go to the supermarket. So instead of going, if you're using batching, you're going to the supermarket, you have the cart, you put everything in your cart, you pay, and you go back home. It's one round trip. But if you don't use batching, you go to the supermarket, you buy milk, go back home. Go back to the supermarket, buy beer, go back home. Go back to the supermarket, bread, on and on and on. So that's exactly how batching works. And it works for update statements, and it also works for delete statements. It is just the same property. It applies to all of these statements in Hibernate. However, it's not enough. If you set it in Hibernate, you might want to set these two properties, order inserts and order updates, to true, because otherwise, if you're using cascading, you have the parent, it saves the parent, it cascades to children, to child entities, then it goes back to the parent. The problem is that if you're not ordering, the fact that you're switching from one statement to the other, it has to flush the batch. But if you're ordering them, you can batch and group them together. So you save the parents, and then you save the child entities. So that's why, if you're actually in Hibernate, if you set the batch size, you want to set these two ones. They are not set by default for, let's say, historical reasons. Nowadays, CPU is not much of a problem like it used to be 15 years ago. So, and another one which you might want to set, especially if you're using Hibernate 4 or Hibernate 3, this one, batch version data. Previously, if you're using optimistic locking and you set batching would be disabled, because the previous Oracle driver did not work very well when you combine both of those. But nowadays, if you're in Hibernate 5, you don't have to worry unless you're using the old Oracle dialects, which, by the way, you can still upgrade the driver and use the new dialects. You can even use the new Oracle driver even if you're using an old version of Oracle. So you can use the 12 driver with Oracle 11 on the server side, because the driver is both backward and forward compatible. Okay, one of the most important part related usually this where things really go wrong in terms of performance is because most of the time people fetch more data than they really need. So when it comes to fetching, there are several things to keep in mind. One thing can be the fetch size, the JDBC fetch size. Also the result set size. There are things like when to fetch DTOs, when to fetch entities, and also relationships play an important part in this when talking about fetching. So now the fetch size, this one is one property which is strictly related to how JDBC works. One thing about JPA in Hibernate, just because it allows you to not to deal with the verbosity of JDBC, you still have to understand how the driver works, because when it comes to performance, even if you're using a framework which gives you a better abstraction, which is much more developer friendly, you still have to know how the database works, how JDBC works, because you can tune up several things even on the JDBC layer, which is completely unrelated to Hibernate. So here, related to the fetch size, usually in Postgres and MySQL, if you're using those, the fetch size will, when you're executing query and you get the result set, it automatically prefetches everything on the client side. So by the time you iterate the result set, everything is on the client side. On the SQL Server, it uses some adaptive buffering, so you don't really have to do anything. It just prefetches data on demand. On Oracle, the problem is that the default fetch size is just 10. So what does that mean? If you're selecting 1,000 records, it will have to go 100 times to the database to iterate the results, to materialize the result set. However, if you're using Hibernate, you always materialize the result set, because Hibernate does not give you the result set. It gives you either a list of DTOs or a list of entities. So you always iterate through it. So especially if you're using Oracle, you might want to increase the fetch size to something which is much more meaningful, like 100, 200, or something like that, depending on how much data you are fetching from the database. And that's a global setting. You can override it on a per query basis. You can use these hints, which are very badly named. This is JPA, they call it hint. If you take a look here, it's like create query hint. You might think about that this is a database hint, which is not. This is just a JPA provider hint. So the provider takes this into consideration, and Hibernate will use it and set the fetch size for this particular database statement. However, and if you have to measure it, like for instance, when you fetch 10,000 rows and you set the fetch size to 1, that would be 10, and here 1,000. You can see that the more you reduce the number of round trips to materialize the result set, the better it goes. So yeah, especially if you're using Oracle, you might want to change from that to something which is higher than that. Okay, now if you think about, so yeah, increasing the fetch size will give you better performance, but then you never need to fetch 10,000 records. I keep on seeing this on the Hibernate forum, on Stack Overflow, people asking, it's working really bad, you know, I'm fetching 200,000 records, 1 million records, and it really takes a lot of time. And then I ask people, why do you fetch? What are you doing with all that data? Do you really need it? Well, come on, you know, if you have a mobile phone and you are selecting, you know, like, you know, you have the repository in Spring and you have a method there, find all. Find all, what's all? 1 billion records. You'll get 1 billion records on your mobile phone. And that's really bad, because you cannot display it on your page, on your desktop. If you have a table, probably 20, 25 records are enough to display for a page, and then you can use pagination. Or if you have a tree, you can use to fetch just the branches which are visible, and then on demand fetch more. And usually what's even better is just to provide the user the right filtering criteria. However, most of the time it's better to use something like that. If you don't use pagination, it's like a blank check, you know, you can just write the sum there, so you know, it's not very wise. So most of the time it's better to just set how much data you really need for your application. And that also works very well for batch processing, because even in a batch process, you don't have to process hundreds of thousands of records. It's much better if you process smaller batch sizes, which you can process in parallel using multiple threads, and make sure that the database transactions are quite short, that don't take a lot of time. So this is this is quite a general hint that it's much better if you're using pagination. And what's nice about this in Hibernate is that pagination, when you use this API, works both for JPQL entity queries, but it also works for native SQL queries. And for instance, if you have to fetch 100,000 versus 100 rows, you will see that it takes way less time. And what's more important, if you're setting right from the very beginning, and if you're using pagination, and if you only select 100 records, the execution plan can benefit from indexing. Otherwise, if you have a lot of data and you have to select 100,000 records, the execution plan will not use an index because it takes much more time to use the index instead of scanning the whole database table. So also keep that in mind. Okay. However, you might, if you're reading this blog post, which is very good on the internet, is from the person Marcus Winand, who wrote SQL Performance Explained. And there he says that the default offset pagination, which is also used by Hibernate and the vast majority of frameworks, data access frameworks, he says that that does not scale well if the result set is considerably large, which is actually true. If you are actually having to scan a result set, which is or on the database side, even if you're selecting 100 rows, but have to scan on the database size 1 million records, if you're using offset pagination, you will have to go through all of them, so the index will have to be traversed, so you have to load from the disk or from the memory. So there's a lot of work to be done. And in that case, keyset pagination, which uses the ID, is much more efficient. However, even more efficient than keyset pagination is just you reduce what you are selecting from the database by using more meaningful search criteria. Have you ever searched for something in Google and went to the last page to see how many pages? Do you know how many pages does Google allow you to see on a result? Only 15, between 15 and 30. That's it. So even if you can try now, search for SQL or for Java, it will say that it found 300 million records. But then you cannot go to the 300 millionth page. You only limit to 18. Why? Because it doesn't make sense to just go. It's not even user-friendly to use that. So if the manager says that, no, I really want you to implement something and to have 16,000 pages there, that's not really user-friendly. What you want is to have a toolbar there or a text area where you can provide more filtering criteria, because the user is interested in finding the right results, to restricting the whole results to something that is just 10, 20, 15 results, which they can inspect and find exactly what they are interested in. Okay, now that was about the number of records, but also the number, how many columns you are selecting is very important when you're using JPA and Hibernate. By default, you're something here, it's select star, everything. And for a DTO projection, you just might want to select only the columns which you are interested in. So for instance, if you're selecting, like here, if I remember correctly, it used to be like 15 or 20 columns instead of just one, the performance is quite staggering when you are selecting just a DTO projection. So DTO projections are actually very good if you're having read-only views, tree structures, tables, window functions with reports and stuff like that, things that you are never modifying. And on the other hand, entities are very useful. For instance, if you're writing data back to the database because you're loading the entity, and then Hibernate can take care and track the modifications, and then it can issue the update, delete, insert statements for you. It's also good if you're using multi-request logical transactions. For instance, you're loading the entity in one request, you're serving it into the browser, the user can do operations on the entity, and then you come back in a different database transaction to update the record. So then you can use the same entity, and if you're using optimistic locking, you can even protect yourself against lost updates. Or the same can be done if you're using the persistent context type extended. So for these purposes, if you're writing data, the entities are very useful. Otherwise, if you're just reading data, it's much more efficient to just take the DTOs instead. Now, another thing about fetching data we discussed about entities is about associations. Now, the biggest problem about association is that before JPA, in Hibernate, everything used to be lazy here. That was Hibernate 3.0. JPA came, and then they decided that the many-to-one and one-to-one should be eager. The reason why they really wanted to have that is because they didn't want the developers to be forced to use proxies, which is actually not using proxies with a framework like Hibernate would not render very good performance. So in the end, everyone would still use it. However, that happened in 2006. It's not like they can change it nowadays. The problem is that many will just declare many-to-one and one-to-one like that without fetch type lazy. What problem can arise? Except from fetching too much data, you can also go into n+1 query issues and stuff like that. So it's much better if you just set every association to lazy and just override the laziness to eager on a per query basis. So basically, you can do that pretty easy if you're using join fetch, if you're using entity graphs, fetch profiles, and if you're not fetching the data, but then further away down the stack you need it, you might get this lazy initialization exception. Have you ever got this lazy initialization exception? I mean, in your life, if you're using Hibernate, at some point it's almost impossible not to get this lazy initialization. It's like a rite of passage when you're using Hibernate. So now, you know, because it's very popular, there are also very popular solutions. You know, like some people used to call this open session in view pattern, but it's not a pattern. They forgot that to put the anti in front of it, because actually this is not a pattern. It's just a bad idea. So what actually happens, and you know, this is a general bad idea, and actually it's, you know, you might think that, who uses this? I mean, what framework would ever want to use open session in view? You know, a framework like Spring Boot, for instance. And you know, we had one discussion on GitHub, which I think it took like 8 months to convince them to just add a warning message. So it's very funny to just read it. It's, I don't know, 50 messages there. Nicolas also commented on it. So it's funny just to read and to see the opposition for people to no, but I really like this pattern. So what happens with open session in view? You enter in you have a web filter. There you are starting your session. Because you're starting a session, it doesn't mean that you really started a transaction. The session doesn't have to be associated to a database transaction or to a connection. So it's just detached to this point. So now you go to that would be the disperse servlet, that's the controller, where the MVC layer is. And then now you get into a real service, which you have here, somewhere here, a transactional annotation. Then at this point, you start the database transaction, you do everything there, it's fine, everything happens in one transaction, everything happens in one database connection. You get out of this layer, the connection is closed, now you go back to the web view. So what happens? Now you have lazy proxies, which have to be initialized, and they will be initialized because the session is not closed. But what database connection and transaction are you going to use? Because that was closed. So what connection you are going to use? One connection for every lazy association that you initialize. So you have to go to the connection pool to fetch connection on and on and on, and every transaction like that will have to work in auto-commit mode for every read request, and that puts extra pressure to the data, to the connection pool. And if you will see, if you have many applications and you have auto-scaling, the worst thing you can do is just to have no idea how many connections you really need, and you need to configure your connection pools. So yeah, that's not really a good idea to use this anti-pattern. And another one, which actually, this one is actually worse than open session in view, is this property, Hibernate enable lazy low node trans. The only positive thing about this is that if you're using Eclipse Link and you want to move to a framework like Hibernate, which provides you some other features, which might be quite a good move, that setting makes sense, because in Eclipse Link you have no lazy initialization exception, not because it would be a bug in Hibernate, it's because in Eclipse Link they don't throw the lazy initialization, they work in this mode. So what happens when you have a proxy and the session is closed, you're actually opening a temporary session, and then you're opening a connection, and you're doing exactly this stuff, but even worse, because back in this one, at least you are reusing the same session. Here you're not even reusing the session. So if you're iterating over 100 association, you have to create 100 sessions, 100 database connections in it, 100 transactions which are logged to the transaction log. So yes, this is not a very good idea. The last thing to talk about is about caching. Now, when it comes to caching, you know, there are multiple levels of caching. You know, people go, when you use Hibernate, you know, they focus on this one because it's, you know, it's right there. And what's the lure is that you can activate it via a single annotation. And if you can do everything with an annotation, that's for many developers, that's actually a dream come true. So if they can not get their hands dirty by going to the database, that would be perfect. However, you can actually do a lot of stuff just in the database. So sometimes you don't even need to activate that because actually the database has been evolved to have a cache. All the database for 40 years, not just relational, new SQL, NoSQL, all databases try to do as much as possible in memory and not on disk. So they take memory, they have, like when you're loading a page from the disk, they mirror it in the shared buffers. So then if you keep on requesting the same page, you will keep it from memory, you modify the page becomes dirty, and you only flush it from time to time. So it's quite quite a machinery there going on in the database, which gives you caching. And what's nice about the one in the database and the operating system is that it's perfectly consistent. So you don't have to worry about consistency issues. On the other hand, if you're using on the service layer, the more boundaries you bypass, the more performance you will benefit. But the least is going to be much more difficult to get consistency. So if you're using something here like memcached or Redis, you will see that, okay, it's very performant, but ensuring that it's one-on-one with the database is going to be much more difficult to do. And Hibernate is somewhere there in between, because it can give you performance, and you can use one which provides you consistency. And where it's really useful to use is not for reading data, for queries. Because for queries, it's quite simple to scale. You just spend more follower nodes, so you get better processing. You need more raw power, just spend more nodes. You are using replication. So that scaling reads is actually very easy. That's why MySQL is very popular. You can just scale reads extensively. It works very nicely for web applications. However, what's difficult to do is to scale on a single primary node. Scaling there is much more difficult because you only have one node, so you can only scale vertically. So here's where the second level cache can help you, because it allows you to offload the master node to take some read requests from there and to serve them from the second level cache, which is strongly consistent. So you will not run into consistency issues, because we all know that there are two hard things in computer science: cache invalidation and naming things. That one is impossible to fix, but at least we can fix the cache invalidation thing using something in Hibernate like read write or transactional. Those two, if you use them, they are strongly consistent. That one is not strongly consistent by design. It's not a bug, it's a feature actually, because it's meant to be used in a distributed system where you cannot take locks. So yeah, it allows you to still use caching, and as long as consistency is not an issue for you, at least you can get better performance. And it's not just goes to entities, because you can use this second level cache for collections. So you can activate it with the same setting, like for entity caching, and it will store the identifiers, and then using the identifiers, you can go to and load the content of collections. And what you can achieve, for instance, you can achieve the same thing you would achieve with Redis, but actually it's better from one perspective. You can store an entire aggregate, the post with counters, votes, comments, and everything there. So instead of going to the database and issuing lots of joins and queries, you can just load everything from the second level cache. And what's nice is that it, unlike a hierarchical cache, a key value store where you store everything, all the tree, hierarchically, this one is nicer because if you're changing something like the board, only one region will be modified, only one entry, instead of having to invalidate a large number of records. So basically, that's pretty much it. We went through all of them. I hope it was useful for you. Now, if you have questions, please don't be shy and address them. Any questions, not just any question about Hibernate. Challenge me. Yes?
It seems like when you have many lazy relations,
Yes.
touching one of them will actually load all of them.
When you have multiple lazy relationships and you initialize one, and then when will that happen?
In one of our entities, we have like, or in many of our entities, we have many lazy relations.
Shifts, yes.
If you monitor what it does, then when we instantiate one of them, it actually do it for all of them.
No, it shouldn't happen like that. So if you're only hitting one proxy, only that proxy should be initialized, not the other ones, unless you're using something like batch fetching or subselect fetching or stuff like that, which you shouldn't really be using. If you're having many to-ones or one-to-ones, the best way to get them is to just use the join fetch. That's the most efficient of all. So you don't have to worry if you're having 10 or 20 joins there, because those never fan out. So if you have 10 records that you select, even with 10 joins, you're still going to get 10 records. The problem with joins, if you're having 10 records and then you fetch another one which has another 10, is 10 by 10, and then you have another one which is another 100, so it's 100 by 100. So then you have a huge result set that you have to send to the application. So usually if you're having only one-to-one, many-to-one, it's quite efficient to just join fetch them, and at most one collection. And if you need more collection to initialize, first of all, you have to reconsider your design, and second of all, you can use the Hibernate initialize to initialize them. However, most of the time you don't really need to do that. Why would you need to fetch one aggregate with everything there? Everything. So you might always think about, do I really need all that data, and for what exactly I need that? Most of the time when that happens, you should always think that maybe it's okay to just fetch a DTO projection, because in Hibernate, you can fetch a DTO projection with children and construct the whole hierarchy of DTOs. It works with a result transformer. I have an example on my blog. Just Google Vlad Mihalcea result transformer. So yeah, that question, you can send me a pull request that demonstrate that, because it shouldn't happen like that. If that happens, it's a bug. Yes?
Concerning the ID generation, I know that some people don't really like sequential IDs, because then the person can guess which is the next ID. So if they have a record, they can guess, okay, so if I increment by one, I can take another one. And in some cases, they use universal UIDs, then it's more string than something like that. Do you have any kind of performance comparison between string?
That's a great question. So the question is it better to use UUIDs, which are random, or is better to use sequence, which you can guess? From a performance perspective, it's always better to use sequences. Why? Especially if you're using an application like MySQL or MariaDB, or a database like MariaDB or MySQL, or index organized tables, where actually the database is organized as an index. Actually, all the data nodes are in the last node in your index, so the whole table is structured as an index. If you're using a UID there, you are going to rebalance the tree on and on and on, because B3, it does not mean binary tree in database, it means balanced tree. So every time you're adding, it has to rebalance the tree. So if you come with random data, those go here, there, you'll always have to shuffle everything in the index. So you do a lot of database I/O just to sort the whole index. So if you're using that, with MySQL, with MariaDB, with Oracle index organized tables, it will not play very well. It works okay with Postgres, with Oracle, if you're using heap indexes. In that case, it's okay to use that. The other problem is the size. The UID takes a lot of space, 128 bytes. And it's not just for the primary key, all foreign keys. So you have a root table, you have 5 child tables, foreign keys back to this one, so it propagates. It's not just one type, it's like 6 times more memory footprint, which is stored in indexes and increases the size, which is not a problem if you have 10,000 records, but it's a problem if you have 2 billion records, because there between 128 bytes, or 32 bytes or 64 bytes, you get to, save up to twice or 4 times more memory if you're using sequences. However, there with guessing, the only problem would be if you are sending it to the user. Or if you want to, you might use something in between, you know, to try to use something else, to try to hide it. You can, you know, encode, decode it, or encrypt, decrypt it, or use something like that if you really want, so that they don't see it. So you just have to hide the ID if you want. Yes?
What if the motivation for using UUIDs is more like in the microservices environment you want to avoid collisions?
Yes.
In that case, do you have a choice? Is there another way to manage that?
Well, yeah, the question is, if you're using a distributed systems and you're using UID to avoid collisions, what you can do about it? Yes, actually, if you're doing that, you don't really have a choice. But the problem there is if you're using a multi-master replication, because then you can write to multiple masters. And it's not just the UID. UID is the least of a problem. The problem is that you can write the same, modify the same record, and you have to merge it somewhere down the line. And for instance, do you know how Cassandra does that? Cassandra, NoSQL, uses multi-master. So how does it work when you modify the same record on multiple nodes, and then it has to merge? The last winner, the last writer wins. So it's just a gamble, you know. You come last, you override some stuff. So from a consistency perspective, it's not much you can do about it. So actually, the UID is not even not the highest problem you might bump into. This one about losing updates, losing modification. You might think, I issue an order, you come, you modify, you take my order back, and I don't see my order and stuff like that. So it's, especially if you're playing with money, it's not very useful to have something like that. So what you can use instead is just use a database who was designed to work like that, like CockroachDB. Do you know CockroachDB? CockroachDB, Google Spanner. Those, or for instance, even VolDB. VolDB is quite nice. It's very useful for gaming, in a gaming industry. You store everything in memory, it's distributed. But how it uses it, it always goes to a single thread, or to a single node to execute everything. Because it's in memory, everything is extremely fast, so you have to do everything there. It works something like Node.js in an event loop. So, however, if everything is in memory, it's designed to be extremely fast. So everything happens not in milliseconds, it happens in microseconds. So that's what you can do. So just choosing a database that allows you to do that and avoid the it provides you a distributed environment, but it provides also strong consistency. Otherwise, it's very difficult to work with a data. I have a presentation for that. Yes.
Okay.
Ran out of time.
Vlad, he's always take more questions outside.
I'm going to be outside. You can recognize me. This is me. You can find me there. Ask me any questions there.
Thank you very much.
Thank you very much for coming.